Good morning everyone. Welcome to Suraj School Bhiwadi. Today I Taruna Seni is going to teach you next exercise, that is exercise 10.4, and the topic of today is equal chords and the distance from the center. Equal chords and the distance from the center. Suppose this is a circle and the two chords are equal in length, then from the center what is the distance? So their distance will also be equal. Equal chords and the distance from the center is also equal. So this is the topic of today. So theorem 10.6 tells that equal chords of a circle are equidistant. Equidistant means equal distance from the center. So if this is equal to this, then it means that the distance from the center will also be equal. And the converse of this theorem is that if the distance is equal, then chords are also equal. Okay, so if the chords are equal, then the distance from the center is equal, and if the distance is equal, then chords are also equal. So let us understand example number 2. If the two intersecting chords of a circle makes equal angle with the diameter, means here these two angles are equal, 1 and 2, then prove that chords are equal. You have to prove that AB is equal to CD. Two intersecting chords hai and they make equal angle with the diameter. This is the diameter and they are making equal angles with the diameter. 1 and 2 are equal, and what you have to prove that the chords are equal. So you know very well, we have just now studied the theorem. The theorem is that if from the center the perpendicular distance is same, the chords will also be equal. Means what you have to show, you just have to make these distance equal. If you make these distance equal, then perpendicular distance from the center is equal. So by converse of theorem, you can say that AB is equal to CD. So what is the task? Is to make equal OL is equal to OM. And for making this, you have to prove these two triangles congruent. And for making the triangle congruent, we need three things to make it equal. So let us do. So firstly, I am taking angle LOE, this one, LOE. Okay, let it be 1, let it be 2, so let it be 3, let it be 4, let it be 5, let it be 6. Okay, so what you can write, 1 2 3 4 5 6. So angle 1 plus 4 plus 5 is 180, because sum of angles of a triangle is 180. Also angle 2 plus angle 3 plus angle 6 is equal to 180, because also this is a triangle. But in the question it is given that 3 equals 4. Also 5 equals 6 because it is perpendicular. 5 equals 6 because it is a perpendicular. So angle 1 equals angle 2. What you get? Angle 1 equal angle 2. Here, after doing this, we need three things to make it equal. We have 1, we have 2, and this is 90 degree and this is common. So angle, side. This is 5, this is 6. So what you have, see, angle 1 equals angle 2, angle 5 equal angle 6, and EO equal EO. So by AAS criteria, these two triangle LOE congruent to triangle MOE, and if these are congruent, then OL is equal to OM by CPCT. And if the perpendicular distance from the center is equal, then by theorem you can say that AB is equal to CD, chords are equal. So what we have done in this question, firstly I have used angle sum property in this triangle, then I make the angle sum property equal. This angle cancelled by this angle, and this angle is cancelled by this, because both are 90 and these are equal. Then we got that 1 equal 2, and then this angle 90 because it is a perpendicular, so this is equal, and O is common. Both triangles are congruent to each other, and OL equal OM by CPCT, and then chords are equal because the perpendicular drawn from the center are equal, then chords are also equal. Now we will do the exercise. We have question number 1. Two circles of radii 5 centimeter. Two circle of radii 5 centimeter and 3 centimeter intersect at 2 points. There are two circles. Let it be one circle. Let it be another circle. Now what is the question? The distance between their center is O dash is, the distance between their center is 4 centimeter, and the circle radius is, of the big circle it is 5, and for the smaller circle is 3. And find the length of the common chord. And where is the chord? In the exercise 10.3 we have seen third question that if this is a common chord, then the line joining the center is perpendicular. If this is a common chord between the two circle and this is the line joining the centers, so this is perpendicular and it also bisect. So we have to find out AB. So let it be X. Okay, because both are equal, it bisects, and also that make an angle of 90 degree. The distance between their center is 4 centimeter. Okay, and this is 5 centimeter. So how we will do this? Let us draw the diagram. The distance between their center is 4. This is 5. 5 square minus 4 square, 25 minus 16, that is 9. So this is 9. Under root 9 is 3. So this is 3. So this is 3. So both is equal to 6 centimeter. We have used Pythagoras theorem in this question. Okay. This is 5 and this is 4. This is, we have to find out X. Then it is 3. Double of 3 is 6 centimeter. Next is if two equal chords of a circle intersect within the circle. If two equal chords like this, suppose these are equal chords, if they intersect in the circle, then corresponding segment equal to another corresponding segment. This big segment is equal to this big segment, and this small segment is equal to this segment. So you have to prove this thing. Suppose this is AB, this is CD, and this is L, or you can say O, whatever, then OA is equal to DO and CO is equal to BO. Means the smaller part is equal to smaller part and the bigger part is equal to the bigger part. You have to prove this thing. And what is given in the question, that the circles chords are equal. So what you will do, let us draw a circle. Let us draw the two chords. Let it be AB, let it be CD, let they join at O. Okay, let the circle, let it be M, and let it be P, let it be Q, let it be O. You know very well that if the chords are equal, then perpendicular distance from the center is also equal. So AB is equal to CD, it is clearly given. Okay, and OP is equal to OP will also be equal because the perpendicular distance from the center are also equal. So we will join this to this one. So let these two triangles make congruent. So OP is equal to OQ. This angle is equal to this angle. And this is common. So by using RHS criteria, triangle OPM congruent to triangle OMQ. Understand? OP is equal to OQ, OM common, and this angle equal to this angle. So by using these two criteria, these two triangles are congruent to each other. So we can write that PM is equal to MQ. PM is equal to MQ by CP/CT. Make these three things equal. Now, since AB is equal to CD, so their half will also be equal. Their half will also be equal. So let us take half is AP and here the half is QD. AP is equal to QD. Let it be number 1, let it be number 2. Now in AP add PM, it will be AM. And add MQ into DQ, it will be DM. So bigger part is equal to bigger part, and in the same manner smaller part can be written as the smaller part. Now question number 3. If the two equal chords of a circle intersect within the circle, if two equal chords of a circle intersect within the circle, prove that the line joining the point of intersection to the center, line joining the point of intersection makes equal angle. You have to prove this angle 1 equal angle 2. So just as we have done question number 2, in the same manner you have to make these two triangle congruent. Let it be P, let it be Q. So how we will make the chords are equal. So OP is equal to OQ, OM common, and this is 90-degree angle. So by CP/CT angle 1 is equal to 2. So you have to do question number 1, 2, 3 and example taught. Thank you so much. God bless you.